electric field. So as soon as the voltage exceeds a particular threshold, the domain structure collapses and the appearance is changed. So that's what this as LCDs have to be operated very, very carefully. So you should not give voltage beyond a particular voltage called as threshold voltage. If you give voltage beyond the threshold voltage, then the structure will collapse and the complete appearance of LCD will become changed. And if you start increasing the voltage applied to the LCD further and further, the flow becomes turbulent and the structure turns optically inhomogeneous. Finally, it becomes inhomogeneous. Inhomogeneous means the molecules will start appearing distinct from each other. So you can operate the LCD only within the threshold value. So if you exceed the threshold value, initially the structure will collapse and the appearance will change. Then the flow becomes turbulent and the substance becomes optically inhomogeneous. In this disordered state, the liquid crystals will scatter your light. So whatever light is incoming, which is incident on the crystal, will be scattered randomly. Thus, when the liquid crystal is not activated, it is transparent. So when the liquid crystal is not activated, whatever light is incident on the crystal will be allowed to go inside. Transparent means it will allow whatever light it is falling on it to enter. But when the liquid crystal is activated by a voltage or an electric field, it is going to be scattering the light. And the cell appears to be bright. When the light is being scattered from a particular cell, it appears bright. But when light is traveling inside the cell, it appears dull. Okay. So when the liquid is activated, the molecular turbulence causes light to be scattered in all directions and the cell appears to be bright. This phenomenon is called as dynamic scattering. So dynamic scattering means I am going to apply voltage or I am going to apply a field across the crystal and I make sure that it scatters light. Because when you apply a field to the crystal, all the liquid molecules will be oriented along the direction of the structure, which will not allow the light to pass through the structure. It will become opaque, so it will start scattering light. So this phenomenon is called as dynamic scattering. So that is what the structure you have seen here. You are going to have two glass plates, and on the bottom, on the inner side of the glass plates, I am going to have transparent electrodes which are coated with tin oxide, and below the two electrodes, I am going to have my liquid crystal. So as I apply the potential between the two electrodes, the liquid crystal molecules present in this gap start aligning themselves. They will start aligning themselves and they will become opaque. When I remove the electric field, they will go back to the original form and they will become transparent. So it's just like on and off. On means the liquid crystal is transparent, it is going to allow the light to pass through it. Off means it is going to be opaque, so whatever light is going to be incident on the LCD will be scattered back. So based on that, you have two methods of operation. One is called as field dynamic scattering type, next one is field effect type. So what we have seen here is dynamic scattering type. Okay, it happens because I'm going to apply a field and I'm going to scatter the incoming light in all directions, so such that my liquid crystal cell is going to appear bright. So this phenomenon is called as dynamic scattering type. So next one is field effect type. So the construction of field effect type is similar to that of the dynamic scattering type. Only thing that each two thin polarizing optical filters are placed at each glass sheet. So you know, in the inside the glass sheets you will have electrodes in dynamic scattering type, right? But in field effect type, in addition to the two electrodes what you have, we are going to place optical filters. You know, filters are used pass or reject some particular components. Optical filters means some colors will be allowed, some colors will be stopped from passing. So that is the purpose of optical filters. So optical filters allow some colors to pass through and so they will reject some colors which will not be allowed to pass through. So here the LCD is made up of pneumatic type which twists the light passing through the cell when the latter is not energized. So when you don't give any voltage or field to your crystal, what happens? It will twist the light. It will change the direction of polarization of light as the light passes through it. So this allows the light to pass through the optical filters and the cell appears bright. Okay, so when I am not going to excite my liquid crystal, it is transparent, right? So it allows the light to pass through. When light is going to pass through this LCD crystal, it is going to twist the polarization of light. It is going to twist the light. It will change the direction of polarization because it is not having any electric field setup. So all the molecules are randomly oriented along a particular direction, right? So it will twist the light passing through the cell, so which is not energized. So this will allow the light to pass through the optical filters and the cell will appear bright. When the cell is energized, no twisting takes place and the cell appears dull. When the cell is energized means when I'm going to apply a voltage or electric field across the cell, the light will not be allowed to pass through because the liquid crystal becomes opaque, right? So it will not allow the light to pass through. So no twisting of light takes place and the cell appears to be dull. And no light is going to pass through the optical filter. So only when light is going to pass through the optical filter, when you look at from outside, the cell is going to appear bright. But when you're going to apply a field and you're not going to apply, you're not going to allow the light to pass through the LCD crystal, then the optical filter has no input. So the cell is going to appear dull because no twisting of light